Okay, Year 9, welcome to your second part of looking at extended applications of index law. Yesterday we looked at multiplication, today we are going to look at division. So, this is the same thing that I wrote down yesterday. If you didn't get it, write it down. It's basically saying that today we are going to look at a combination of numbers and pronumerals and what happens when we try and raise them to a power. We're going to look at how we can simplify them using a multitude of index laws. As we did yesterday with multiplication, today we are going to look at division. Division. Okay, let's
Division.
go. That was Joel. He said division. That was a bit rude for interrupting. Anyway, okay, simplify the following. We have in the bracket 6 divided by p. Now, we've known for the last 3 lessons that this indice here, this raising to the power of 3, okay, belongs to everything within these brackets. So that's another, 6 divided by b in brackets to the power of 3 is another, far out, I can't speak English today, is another way of saying 6 to the power of 3 divided by b to the power of 3. So we can write this as 6 to the power of 3 divided by b to the power of 3. I can simplify one step further, remembering again that we're asked to simplify the following. 6 to the power of 3. 6 sixes are 36. 36 times 6 is 216. B to the power of 3. Can't simplify any more than that, okay? That's the most I can simplify. Can't do anything more than that. This next one, negative 2a to the power of 2 divided by 3bc to the power of 3, all to the power of 4. Now, the thing with these is that they look really tricky. They're not actually. You just have to take it one step at a time. So, this is how I do it. Negative 2 to the power of 4, let's just expand it out. A to the power of 2 to the power of 4 becomes a to the power of 8. Divided by 3 to the power of 4. Okay, I'm just writing how I'm expanding it. B to the power, now that's like b to the power of 1. 1 times 4, b to the power of 4. Okay, c to the power of 3 to the power of 4 becomes c to the power of 12 because I multiply the indices. Okay. Now that I've got it all expanded, I can start working out the numbers. Negative 2 to the power of 4. Negative 2 times negative 2 times negative 2 times negative 2. Okay, positive 16. Okay, and that a to the power of 8 stays the same. Okay, 3 to the power of 4. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 becomes 81. Okay. Okay, 81, b to the power of 4, c to the power of 12. Okay, I look at 16 and 81. Okay, and I ask myself, can I simplify that any further? No, there's not a number that goes into both of those. The other thing with it as well is there's no a pronumeral on the top that there is on the bottom. I've got B's and C's on the top and an A on the bottom, so I leave it that way. My very last example looks really hard, but it's actually really easy, okay? I just have to hold my horses, okay? X to the power of 2, y to the power of 3 divided by c to the power of 3. Okay, first off, let's expand it. X to the power of 2 to the power of 3 becomes x to the power of 6. Oh, that looks dodgy. Y to the power of 3 to the power of 3 becomes y to the power of 9. Okay, divided by c to the power of 3. Times, let's expand this out. X to the power of, well, there are ones in there essentially. Ones. Okay, that becomes x to the power of 4, c to the power of 4. How I'm getting that is x times x times x times x is what it's asking me to do. And then y to the power of 4. Okay, this next step. Okay, I remember when I have a fractions, it's my numerator multiplied by my numerator, my denominator multiplied by my denominator. So now we're combining some past knowledge that we've learned in a previous topic. Let's deal with them pronumeral at a time. X to the power of 6 times x to the power of 4. Okay, I know when I'm multiplying with indices and my bases are the same, I just add them. So that becomes x to the power of 10. Y to the power of 9 times c to the power of 4. Well, I can't do that, so that just becomes y9, c4. I leave that. C to the power of 3 times y to the power of 4. I can't combine any of those, so they just stay the same as well. So, all in all, x to the power of 10, y to the power of 9, c to the power of 4 divided by c to the power of 3, y to the power of 4. Here's the interesting thing. I've noticed that there's a y here and a y there. I've noticed that there's a c here and a c there. I remember from when doing algebra that if I have a pronumeral on the top and a pronumeral on the bottom, I'm able to cancel them out. I've got 3 c's on the bottom and 4 c's on the top. That's what that's essentially saying. Okay, it's essentially also saying that I've got 4 y's on the bottom and 9 y's on the top. So let's see what I can do. I've got x to the power of 10. 3 c's cancel out on the bottom, which leaves me with 1 c on the top because there was 4 on the top originally. Okay, 4 y's on the bottom cancel out with 4 y's on the top, which leaves me with 5 y's on the top. Which leaves me with just 1 on the bottom, or it as a whole. So y to the power of 5, c to the power of 1. I better make sure it's all over 1. So, I mean, you don't have to write it over 1. That just cancels out. Okay, I kind of need to make sure that if my final answer, I don't leave the 1's in. Okay, so if I write them there to remind me, I have to make sure I get rid of them. And this is my final answer after I've simplified. X to the power of 10, y to the power of 5, c. And that's it, guys. That's dividing with index law extended.